Welcome. So I thought I'd try a few game engines for once and see if I can kind of get my fill of programming with them. Now, I am a C++ programmer. I don't particularly like using blueprints and nodes type workflow. I can, it's okay. But I really wanted to try Unreal with the C++ development. But when I went to actually make a C++ project in Unreal 5, I came across this little error that basically said I didn't have some version of .NET installed and then some version of .fx, and essentially it just didn't work. So here is the error. There it is. And I did try to resolve this. I went in and installed that stuff, rebooted, tried again, same thing. I think it might have said I needed something else. I don't know why. I'm pretty sure I have all that stuff installed. Here we go. So I try Unreal 4.26 just to see if, hey, maybe it's Unreal 5 that's the problem. So I put Unreal 2.6 in C++ and tried to create same error. So I give Unity a go. Let's give Unity a go. Maybe I can do some scripting here. I know it's C#. Get in here with a new project and I just search up scripting in Unity and look for a suitable tutorial to start with. Now I probably don't want the beginner stuff because it's going to try to teach you beginner programming stuff, and I'm a little bit past that, so I go for this intermediate scripting, and this is where I dive into some tutorials. So I am going to walk you through a lot of this Unity stuff, and you will probably learn a lot about Unity scripting by watching the rest of this. But if you really want to learn, go watch this free tutorial that's on the screen now. It's a lot longer and more robust than what I'm going to say here. I'm basically going to give you some quick overviews of what I learned. So in its most basic form, all you do is you create a script in your assets, and then you can end up attaching that to any game object, including an empty game object if you just want it to exist in your world. Let's go over here and click Add Component, choose a script or a script, and that's basically how you get these scripts going in this engine, and you can double click them to open them. So in the first script of these tutorials, it basically has you make a private int experience and has you set up some getters and setters, which they are calling properties here. They're sort of like an automated little getter setter system they have. And you can specify new variables like this level here that returns based on your experience, and also has a set based on your experience. And also you can go further with this. There's a little shortcut here which is plain old get and set if you don't want to do anything super specific and just assign or get values. Of course it actually needs a variable to get and set, which they didn't include in the tutorial, oddly enough. Alright, next they go over the ternary operator, which is exactly the same as C++. It's basically an if-else with a little shortcut. So we'll show a quick example here. Here's this is alive that basically returns true if your health is over 0 or false otherwise. Very straightforward example of a ternary operator, but you can basically return one thing or the other, and it's a bit of a shortcut optimization a lot of times. And to make things show up in Unity, it looks like you gotta make them public, which makes sense, but that doesn't work for the properties, only for the actual variables, it seems. I thought it would work for the whole properties thing too, but okay, so we went in here, make sure it's in there, yep, shows it, and you can change it right here in the editor, so that's kind of a cool feature. Next up on the list to learn was statics. Statics work exactly as you would expect, same as in C++. In this example, they have us create an enemy script. And basically what we're going to do is get rid of these initial methods and just store a public static int of the enemy count. And anytime we instantiate an enemy, increase this. A very common use of static. It's just to keep track of how many are initialized. And in the destructor you can put a decrement too, but I don't think they go that far here. And they basically say you can do the same thing with the player. These are pretty basic uses of static. There's many more advanced uses of static. But yeah, it's a static. For the players, they do it on start rather than on the constructor, as a way to check how many active players are in the game or something like that. And then we're going to make another one. Just a little player manager. And here we could also do some stuff like see how many players there are when we start this player manager. And we'll make yet another file, and this is just going to be a utilities example where basically you can access this from other classes. So you can build some functionality into here, like functions you commonly use, and then you can just use them from any of your other scripts, and that's sort of a handy thing. But there are some other things we want to do to it, like get rid of these other methods here, and we're going to end up getting rid of mono behavior and turn it into a static class. A class being static means it can't be instantiated, and taking off this mono behavior basically gets rid of the inheritance from the Unity stuff. So if we don't need that, we can get rid of it. Next we get into method overloading. This also works exactly as you would think. Basically the same as in C++, where you can specify different types that the function takes, and that makes it do different things or run a different function. Next we get into generics, which are basically templates. There's not really a whole lot to say about these templates. They mostly work as you would think. There are some special things you can do, like this where at the end. This basically allows us to say it has to be a class or a struct, which is a variable, or something else. And here we'll just show some examples of putting these little templates to use. And next up on the scripting tutorial is inheritance. It works exactly as you would think too, about the same as C++. The whole parent-child relationship and public, private, protected, and also the whole polymorphic features. It also has those, so we can cast and check things and call base constructors like that. And next we're going to look at polymorphism, because sometimes you want to know if something is so basically you can check if a child has a parent class and all that stuff. Pretty standard polymorphic stuff. Now we're going to talk a little about member hiding. Now basically this is the use of this new keyword to say that you use this child class's function or value no matter what instead of the parents, I believe. I think that's all it does basically. Next we're going to look at overriding, which is basically creating functions in the child class that override all the previous ones, and you can do some special tricks with that. This is pretty standard stuff here. And hey look, you get points when you complete these little tutorials. Next we're going to look at interfaces and kind of see what they do and how they work. Now basically these are just front ends for some functionality, but you still got to build the functionality somewhere. So it's kind of like a promise that these kind of things will work, but you can also go through and check if something has an overloaded method to see if you can call it. And next we're going to look at extension methods. Now these are methods that you can tack on to a previous class. So it's a pretty neat little feature to be able to just extend a class that you're not allowed to edit. And basically you just make a function and you take in this, which is the type of the class, and you perform some operation on this, and it extends the class with this new functionality. Pretty cool. What is the equivalent of this in C++? So then you can just call that on your transform, and as you can see, it even pops up in the autocomplete stuff, which should be pretty handy. You can just see your extensions. Next we're going to look at namespaces. These also do exactly what you would think. They're about the same as they are in C++, but you also get to them with the dot operator rather than the double semicolon, so that's a little different. So next we're going to look at lists, and you might want to have a list of something like bad guys. Lists are like linked lists, or doubly linked lists in C++. So they're very nice for adding and removing data. They can do that, and they can resort themselves very quickly. So that's the nice thing about lists. But they're not necessarily contiguous in memory, so they can be a bit slow if they get huge. And then we're going to look at dictionaries. Now, dictionaries are basically maps. You have a key, which is the first value, string here, and the second thing is what that key points to. And here we just have a dictionary of bad guys and some examples of adding to it. So pretty standard map stuff. And of course you can get to the value you want by just putting in that key. And there are some try methods to see if it exists, but these are pretty slow. Next we're going to look at coroutines. These basically allow you to do something and yield return null until it's finished. So allow you to put like a function within a function type of thing. And then next up we have some quaternions. Yeah, I looked over quaternions. No, I'm not going to go over them, but it was actually a pretty good little quick watch about them. And then delegates. Now, delegates are something like lambdas. You can basically point them to functions of the same signature and they hold that. So you can basically change them on the fly as needed by pointing them to a new function. And do all kinds of little tricky, hacky stuff with delegates and switching them up as needed to new functions. So yeah, I don't know how I feel about these. They basically feel like weird lambdas. Lambdas created with the auto property or something. You got to be careful about this delegate keyword, and the signature has to be exact for anything you point it to, and you can plus add things to them or minus things to them so they can actually do multiple functions in a row. Like this will do power up and then turn red, and then you can also check for null to see if there's anything actually that's pointing to right now. All right, next we're going to look at attributes. Now these basically are for the Unity editor, and they help you control what it shows. And just like as a quick example here, we can put this speed within a range within the syntax, and yeah, you just basically put it before it, and then over on the side you're going to get the ability to have a slider for it. Here you see we can put execute in edit mode on the class, and then the script will actually be running while you're in edit mode. Not sure how dangerous of a function that is, but it's something you can do. Next up we're going to look at events. Now events use delegates to do some kind of action. So here's an example of an on-click. You can see here we've declared our delegate, which is a void that takes nothing, so that's our click action function that it's going to assign to, and we have a event here with the keyword event. And we had a function down there, but we're going to assign it to teleport so that when we click that button, we're going to do this teleport. And as you can see, the on clicked, you can plus or minus things from it just like a delegate. You can also assign it multiple things if you want. So here we can also have this turn color function, which is void and takes nothing. And that is pretty much everything that the intermediate scripting went over. Hope you enjoyed. See you guys in the next one. Peace out.